were the same, but our sides were just in the same proportion. You ransack mo no. Proportions. Yeah. Okay, so we are going to find a scale factor, ratio of perimeters, and ratio of areas, and then we'll see a pattern, and it'll be much simpler for us. Anywho's, who knows the scale factors? Remembers the scale factors?
There's a lot.
Good. Okay. In the left triangle, what's my side length?
8.
8. And the right triangle, what's my side length?
4.
1/2.
Oh.
2 to 1.
I
2 to 1. Yeah. Reduce. Becomes 2 to 1. Our scale factor is 2 to 1.
You were already wrong. You said this wasn't that bad.
We can't divide. Who
No, I think this.
You don't even know what we're doing here.
Okay, perimeter. Tell me the perimeter of my left triangle. What is it?
24.
24. How did you
Get it? 8 times 3. Add them all up. How about the perimeter of my right triangle?
12.
12. 4 times 3 would be
2 to
12.
1.
Colin, you gonna be alright? Oh.
16.
What'd you say?
2 to 1.
What's 2 to 1?
The ratio of perimeter.
The ratio of my perimeter is 24 to 12. Can be reduced to 2 to 1. Crazy.
Nuts.
Okay, I want to hear 0 Brones.
This is
Area of a triangle. How do I find my
half
formula?
base times height.
Half base times height. What kind of triangle is it if they're all the same? Equilateral. What are our angles in equilateral?
60.
60. So you're saying this is a 60. And you said area of a triangle is half base height. What's my base?
8.
8. So I got half.
Half 8 of 4
Okay.
square roots of 3.
Thank you. What's my height?
4 square roots of 3.
4 square roots of 3. Because this little princess is 4. This little piggy is 4 square roots of 3. Yeah, I'm just trying to you guys are all like that. Just trying to make fun of myself. So if I multiply those together, half base is
16
4.
square roots of
I
3.
get yes. 16 square roots of 3. Guess what? Doing it again over here. What's my base of my little smaller triangle?
4.
4. Are you crying?
I need to fall asleep.
Oh gosh. What do we think the height's gonna be?
2 square
2
roots.
square roots of 3. Yes. Half of 4 is
4.
2 times 2 is 4. So this is 4 square roots of 3. Okay, so we're going to compare these two guys. So 16 square roots of 3 compared to 4 square roots of 3. The
That's
square
4
roots
to 1.
4 to 1.
Yeah, 4 to 1. Notice how that's different?
Yeah.
Could you like just taken the base times the height though, and then divide 64 by 16?
I don't know what you got. And
Come down to the
welcome. There, buddy.
Okay. How about scale factor here? What's my scale factor of my left guy and my right guy?
I'm talking base or height.
What is it? 8 to 6, aka
2 to 3.
whoa.
4 to 3. 4 to 3.
8 to 6, aka 4 to 3. I always try to pick the small sides because then can't reduce them. Okay. Perimeter of this guy. If this is 8, what's this?
8.
This
4.
perimeter
24.
24. Same thinking over here. 6 on top, 3 to the side. What is my perimeter of this guy?
18.
18. So my ratio of perimeters is 24 to 18. Can I reduce that?
Not to what?
Four to
4 to
3.
3.
I'm seeing a pattern. That's good. These will be nice. My area. What? 32 base times height. 32. Area here. 18. So my ratio of areas 32 to 18. Reduce. Find common number.
8.
I don't think 8 goes to 18.
8, 6.
Let's start with 2. 2 goes into both. How many times 2 go into 32? 16. How many times does 2 go into 18? 9. Is there any number that goes in both 16 and 9?
No.
No. Done. Okay. We're gonna work off of our patterns. So I heard someone say they found a pattern. What's pattern you noticed?
They're all
Scale
the same.
factor.
They're all the same. I don't know about that. Which ones are the same?
For the scale factor and ratio.
Scale factor, ratio, perimeter, same as these here. Yeah, you got an idea? Tell me.
What?
Same thing with the bottom two.
So what I'm hearing is that 2 times 2 is 4, 1 times 1 is 1. 4 times 4 is 16, 3 times 3 is 9.
So do we even have to
So
do
you're
all the
telling
extra
me that this is 4 squared and this is 3 squared. So all I need to do is take my
Well,
Okay.
that's
Yeah,
what
that made
they
that
said.
more complicated. But yeah.
all you're doing is taking your scale factor and squaring it, which is weird because areas, you know how we always label that?
Square.
Square. So to find your ratio of areas, all you're gonna do is take your scale factor and square it. And your scale factor and ratio from are the same. So let's this one that looks super complicated, let's uncomplicate it. What is my scale factor? Pick 2 sides that are the same.
8, 6, and 4.
6 and 4. Can I reduce those?
Yes.
To what?
3
3 to 2. So my scale factor is 3 to 2. What is my ratio of perimeters gonna be?
3 to 2.
3 to 2. All right, friends, here we go. Ratio of areas. 9 to 4. Because we got 3 squared here,
That was
2 squared here. That was, you didn't have fun?
So that was easy. Wait, I have a question.
Tell me.
So, do you want us to do all this work though you just did then, or just
No, I just, let's start off a Wednesday.
okay?
Because then if we make it harder and then easier, then you guys complain less. I just encourage you guys. Okay, the funny thing, it was all right under here. Isn't that funny? That's not funny. Yeah. It tells me the scale factors A to B, ratio of perimeters is the same ratio of the areas, just A squared B squared. Okay, so one more time for the folks at home. The ratio of the lengths of the corresponding sides, tell me top to bottom, what's my ratio?
3 to
6 to 9, and then what, Olivia?
2 to 3.
2 to 3. You always want to put it in the simplest numbers, simplest terms. So, what is the ratio of the perimeter smaller to larger?
2, 3.
2 to 3. Alright, here's the real test. Ratio of the areas. 4 to 9, how did we get it?
Square.
Square of 2 squared, 3 squared becomes 4 to 9.
These are the world's longest numbers.
Okay. Thank you for your comments. I will collect them and destroy them. Okay. Tells me 2 similar polygons have sides, the ratio of 5 to 7. I want to know the ratio of their perimeters, but large to small.
So you just
Flip flop them, 7 to 5. It's the same thing, but they want large first, so we'll put large first because that's we're just talking about these here. Yeah, over it. And large to small, the ratio of their areas.
49 to 25.
49 to 25. Me?
No.
Oh. Of course not. Okay. Okay. Questions so far?
No. Jeez.
80, 10. Okay, so this little guy, it says the area of the smaller regular pentagon is about 27.5 centimeters squared. What is the best approximation of the area for the larger regular pentagon? pentagon. First off, I want you to find your smaller one. Which one's smaller? Left or right?
The right.
The left.
Okay. The left one is smaller. My area is 27.5. Let's rate that guy. I don't know why my two looks so weird. I'm 30. Whatever, dude. Can't even tell which one's smaller. So your suggestions are like in your one ear, other ear. Anyway, okay. First off, what's my scale factor of small to big?
2 to 5.
2 to 5. Okay, so 4 to 10, aka 2 to 5. Well, agree with that?
Sure.
So you'll notice we are talking about areas. So what? 4 to 25. We gotta square these bad boys. 4 to 25. Okay, everybody with me so far?
Yeah.
Okay. Now, we got area. So these are areas, right? These are areas. Ratio of areas. Row up. And I have the area of the smaller pentagon. We're going to set up proportions. So, if I have the smaller area, do you think I should put it on top or bottom? Why the top? Because this is my small friend area. Small people this row, big people this row. Well, I'm short too. Oopsies. We don't know the bottom one, so we're going to put an X there. It'll show up eventually. I promise.
Wait, so would we cross multiply?
Yeah, we're going to apply.
When you do the thing, when you like you find like a pattern or something, and you're like, right, you're looking
You're
at
like,
it.
wow.
Just like off in the distance, right
We're
there.
also confused.
Because I just noticed that.
See, I told you to show up eventually. Okay, so my small area is right here. I'm sorry, it's about 27.5, and we don't know our big area. That's why there's an X. And then somebody had a great idea about cross multiplying. I think that's a fantabulous idea. When I cross multiply, what am I multiplying my X by? 4. So I got 4X equals. Now we all need calculators. I hope we have them. What else am I multiplying?
27.5 by 25.
Yeah, 27.5 times 25.
687.5.
What?
687.5.
687.5?
Yes.
Okay, how am I going to X by itself?
Divided by 4.
Divided by 4. What do you get?
171.8.
19.
How about 172? Because we're approximating anyway.
Okay.
I'm not about to argue about playing that. So 172 centimeters squared. I felt like a whole fight coming.
I think that's just you.
All that work for one answer?
Can we okay?
Is it like 1 3?
Okie dokie. I thought she was crying.
She's not even what she said.
Dying.
Oh, dying. No, dying. Scale factor is 3 to 4. The area of the larger parallelogram is 96 inches squared. Tell me what I should do with my scale factor. If I got areas,
Multiply, square them.
square them. 3 over 4. I gotta square them because we're talking about areas. So my new friend looks like what?
9 over 16.
9 over 16. These are my areas. Areas equals 96 is my
X over
large area. Where's it
96.
going?
X over 96.
X over 96 is on the bottom because 60 is big. And our small friends and big friends gotta go together. Okay, cross multiply how much X? 16X equals how much? 864. X is 54. Okay, now we're talking about area. So we're just gonna steal this label. Inches squared.
Point of all of this.
Say what?
Is there a point of all of this?
Just make that. Anyway,
You know what?
the ratio of the lengths of corresponding diagonals of two similar rectangles, and 3 to 5. So what's my scale factor? 3 to 5. The smaller rectangle has an area of 36. So what should I do with that 3 and 5?
9 to 25.
9 to 25. Square them because then we get our areas. What do you mean? What? Now what should I do?
36 over X.
That equal 36 over x. I got the 9x part. You figured the part.
900.
Really?
Yep.
Sure.
Yep.
Okay. X is
900.
label.
That's easy. Is this all it is? Does it get harder?
Okay, turn the page. I'm glad we're doing so good. I know.
Oh my.
It'll be okay. We're gonna have fun. I'm sorry you're not having fun, but I'm having a blast. Okay. Alright.
Why are you this happy on a Wednesday?
What?
So why are you this happy on a Wednesday?
I don't know. Wednesdays. There's my damn thing. Okay, so the triangles at the right are similar. What is the scale factor? What is the ratio of perimeters? Tell me what we know about scale factor and ratio of perimeters. They're the same. So once we find one, we're like kind of done. All right, notice I have area. Oh, yeah. I have areas, and you know that thing that I showed you back here?
Oh my God.
With the pattern?
This thing?
No. Oh yeah.
Oh, no. Yeah. How we just square our areas. So, like, I'm just going to write where we have right now a squared, b squared, and we want to make it a to b. So, we're starting with our areas, and we want to get to our scale factors. Okay?
So we just square root.
Not exactly. Pause 1 sec. So, I have 50 over 98. True?
Yeah.
Yeah.
Can I reduce this?
Yes.
What goes into it?
2.
2 at least. So, how many times 2 going to 50?
25.
How many times is 2 going to 98?
49.
49. Okay, now, whoever had that great suggestion, was it Olivia?
What? The square root?
Square rooting. Because to get from a squared to a, like we get from x squared to x, we square root. And the reason we reduce
It's
is
5
because
over
these
7.
square roots are much nicer. So yes, dear, our scale factor is 5 to 7. Okay, whoever else said it. So this is both answers. This is my scale factor and my ratio of perimeters. 5 to 7.
They need to be labeled like inches, feet.
I mean, if you're gonna make me outside. Okay, next one. Areas of two similar rectangles are 1875 and 135. I need to find the ratio of their perimeters. So again, I'm starting with areas, and I want to get to not squared stuff. My scale factor. Okay? So let's put these numbers in a fraction together. 1875 over 135. And same as last time, I want us to try to reduce first, and hopefully we'll have nice numbers to square root, because those are not nice numbers. What goes
I know
into both?
125.
5. How many times 5 went 1875?
7.
How much?
Oh, 1875, 375.
Really?
I got it down.
3?
I
Oh,
got it
like
down to
3 goes into them.
Well, no, I reduced by 5 down.
Okay, let's start with the 5s. So when you put 5 into 1875, you get what?
375.
375. When you put 5 into 135, what do you get?
27.
27. Oh. Wait. Oh, yes, 27.
Okay, what goes into both of those? Those aren't nice square roots either.
Maybe.
3.
3 is going up. So how many times is 3 going to 375?
125.
125.
I
How
got
many
this.
times does 3 go into 27?
9.
Are those nice squares?
Yes.
They're square ones. So let's square root them, and what do I get? Ooh, so not a nice square. You guys lied to me. Break up 125. What two numbers? One's in a nice square, I promise.
Whoa.
5.
Hold on.
5 and 5 and what? Make up 125.
15.
5 and 25. 5 and 25. So we got 25 and 5, right? 25 times 5 is 125. What's the square of 25?
5.
So I have 5 square roots of 5, and at least the bottom's nice.
Oh my. Whoa.
Oh my.
I don't.
This doesn't make any
25
sense.
times
No,
5 is
no.
125.
I know. I get that.
And square root of 25 is nice.
Because the square root of 5 is not. Is that just the answer then?
Well, I can reduce that again. So
Hold
stupid. Okay.
on.
Last one.
Wait. Oh, okay. I'm gonna find it.
We have an elementary school that's getting more children from 200 kids to 395. What's 395 really close to?
400.
400. We're gonna approximate here. A parents group is planning to increase a playground, that's super fun, to a larger area. So let's draw a playground. I like my playgrounds rectangular. 200 by 100. New playground. 200 by 400. You drew a trapezoid? Okay, what would you tell a parents group when they ask your opinion about whether the new playground will be large enough? So first off, I need to find area. The area of my small one is how much? How much? 240.
20,000.
20,000. What's this area?
80,000.
80,000. So let's compare these guys. I got 20,000 compared to 80,000. When I reduce that lots and lots and lots of ways down, what do I get?
2 and 8.
2 and 8, which is
1 and 4.
1 and 4. Yeah, that's fine. Okay, let's look at our children. So these are areas. Areas.
What?
What?
Okay.
Are you sure?
Yeah.
Okay. Our children go from about 200 to 400. Reduce that.
2 over 1 over 2.
1 over 2. So if this is my scale factor, is that the area that I should about get? Yeah, because squaring these gives me 1 over 4. So this will be fine. Whether the new playground is large enough? Yeah.
Wait, so the 200
So if you're
divided by
saying
400 scale factor.
Yep. And then the areas we found is our ratio of areas.
Okay.
I did that.
Okay.